Hi, I'm just getting set up here. My name is Jason Johnson. I'm a member of the OWASP Oklahoma City chapter, chapter leader. My presentation is going to be about the HIVE project that I'm currently working on, and and basically what it is it's a capable testing system for people to use for projects, and it started out as a learning environment. And what what ended up happening is a lot of the trials that I went through didn't succeed. So what what ended up coming to it was is it had a gazillion different services that I wanted to use. There's a ton of different OWASP projects out there, and there's a bunch of issues that people wanted to solve. So we wanted to connect the Hive together because without being a Hive, you don't really have much of anything but more than just a capable PC that can run your project on. The other the other aspect was security. We wanted it to be a locking inner grid type security that everything could connect somehow and be really low cost. We wanted the OWASP community to be able to use this, and we wanted to be able to provide a platform that anybody could use. Anybody could, open it up, code however they wanted to, put whatever OS they wanted to on these. And the idea started to stem to development boards like the Raspberry Pi, the BeagleBone Black, Android, basically any type of computer you could find you wanted to make into a node on the Hive. Um, the real goal is to spawn ideas and new projects from OAuth. A lot of projects that are out there right now, you can tell that they just go dormant after so many months or so. Just nobody wants to take them over. And here's kind of a brief overview of what it is now. The picture in the middle is what the Hive in a presentation type mode kind of shows what it looks like. It's supposed to look like a beehive, but it's basically to signify that it's easy to outsource storage of bulk data. And you're probably asking, well, why don't we just use like Dropbox or Google Drive or something, the OWASP, and also your own private Hive or grid. And I'll get into that later, how that actually works. But what was really interesting in this project is there the actual grid will keep your data safe. So you don't have to worry about, you're trying to test an exploit, you're trying to do this, you're trying to do this different kind of things that would otherwise be construed as like, well, you shouldn't be doing that, and now it's on Dropbox, someone's going to get it, things like that. So this is a safe environment for you to test in. It's a safe environment that you set up the storage nodes, you know where they're going. If you have a friend net, which we'll get into here also, then you'll know where your data is at all times, and you'll know it's secure, and it's immutable and mutable, and there's no way that someone's going to get your data. And even if they do, it's going to take a while for them to, be able to decrypt it, uh, get the actual file from it. So, with that said, this slide, I was adding more to the last minute, but currently the Hive is running Debian Wheezy on each BeagleBone. Currently, we do have versions for Raspberry Pi, and I'll show you that in a demo. There's also different technologies, like it's using a twisted for Python for the networking and the actual web server that it runs on the actual Pi. So it's like real low footprint. You don't have to worry about this thing overwhelming. The point of this is that you can take your project, put whatever OS you're working on, use a capable PC that costs about $45. You put your project on there, and then you have somewhere to interface with storage. So say you mess something up, you reboot or format your computer, and all you do is put the link in, and it repairs your files for you. You don't have to worry about going out to your pins or your remote drives, your USB sticks. You can just go to the grid and get your files back, even if part of the grid is down. You can still do that. So when we think of file storage, we think our hard drive. We have our home, which is our root. We have our pictures and all of our files in there. Everyone understands the notation of a security perimeter. It's like a wall around the important things. You rely, upon everything inside. Your security depends upon everything inside the wall behaving as expected. And that doesn't always happen when you're trying to, develop projects and work with things. Nothing performs as expected. So we generally, you care about three things when you think about this kind of approach to storing your stuff in any type of project, whether it be, your personal files or your project files. You want confidentiality, of course, integrity, and availability. And confidentiality is knowing that no one else can get your data. Or, even if they can, you want it's not the right data, or they can't understand what they're seeing. So the Hive will provide both of those in a sense. So this is, your local disk is how we see it. This is your local file system in your house. You got your computer, your files are here, nowhere else. Then you got your remote file system. You got your Dropboxes. You got your Google Drives, Amazon Cloud, Rackspace, whatever. It's very cheap, and it's it's robust. But they try really hard to an upstanding company is going to tell you that how secure they are, but their version of security and our version of security is something completely different. We know that in order for them to keep our data, they're going to have to copy it off someplace. So your data is out there, it's copied, and there's multiple copies of it, who knows where. So we're going to go over how the Hive can provide an environment that will let you fail, in a very nice way. So you can fail and then come back to where you were without having to worry about, your files being out there in everybody else's hand. So here's kind of a cloud sort of image. This is, people around the world accessing your storage, and this is good. And everybody can get there. The problem is there's really no security. You might be going over, SSL or whatever, but that's great. It's just that, and it can be broke over time. Trying to get into your local network is a pain. It's hard to figure out all this, crazy ISP stuff. They block things because they don't want you in. You need a business account and all that mess. Another thing is that disasters. Bad things will always happen. Your computer knocks off the shelf. Something happens. Your kids decide to use the CD tray as a sandwich slot. But these things tend to happen a lot. It makes you sad. You get correlated failures. My data's here, it's broke, there's no way to get to it. Then you have, remote data decorrelated failures. Your data is over here and your house is burning down, but I still have my data. Yay. Another sample of this is like you have the USB sticks or whatever, and you wash it or whatever, and it just doesn't ever work right. Or your file is not the same as what you took off of your computer. And, your most important things, you want them to be secret. Like your social security numbers, your bank balances, and your information account and all that. It's kind of, this kind of slide's kind of weird in the fact that, you keep your local files secret just because you file on that and, the bad guys can't get in, but there's always a way. There's always a way to get in somehow, some way, to get your data out or to see what you're working on or what you're doing. And then obviously over the network, it's a lot harder to keep your data safe. There's always prying eyes. There's always people trying to get in and doing something. So then people encrypt, and they use encryption to encrypt their files and make it harder for people to get in. You're basically transforming the problem. That you're getting smaller keys, bigger keys, but there's still one significant issue, is that when you're uploading your stuff or when you're working on a project or whatever, you're uploading your file. Your file is going across the network in some form. That is vulnerable in a sense. You are in plain sight for however long it takes you to complete that transaction. And your integrity, file integrity is big, especially with any kind of encryption. You want to make sure that what you're uploading to the cloud is what you get back from the cloud, and everything is going to be same and validated that it's going to be the most recent version of what you've uploaded, and it's not some disaster recovered version that they recovered or some Dropbox or something did, whatever may happen. And why this pertains to the Hive is because, like I stated before, your things, when you're developing your projects and working on things, you don't want people having that for whatever reason. So what this basically is going to be a secure, robust file system. I thought when I was building this, I want to, have a computer that people could share, and I thought, well, we'll just share resources. Everybody, if their Hive's not in use, the other Hive will be able to use those resources, their CPU, which can be done relatively easy with clustering. But it didn't really seem tangible. I was like, well, that only applies to about maybe 12% of the projects out there in OWASP. So I thought, maybe something even better would be kind of a secured file system on top of being able to share everything across the board, resources from a BeagleBone. And when we started this, we started it with a Raspberry Pi. Raspberry Pi is a great tool. It's very cheap, about $25. It can run a ton of different OSs, and it has one fallback, is that it's slow, and the power consumption is very, very tricky. You got to have really clean power. It has to stay exactly at 5 volts, otherwise you get what's called a brownout, and the thing just sets and restarts. So that was kind of a drawback. I wanted to be able to beat this thing up so that it will last through any type of testing that we're doing. So what ended up happening is we started to develop on Tahoe. I'm not sure if any of you know what Tahoe is, but I'll go over what can be done. Basically, it's a structure. It started back in 1999. It's been around forever. Not a lot of people have heard of it. It uses very reliable storage solution. So basically, it's a gateway that it contains an embedded web server which clients can manipulate the files through a simple RESTful HTTP protocol. So it has a RESTful service as well. So I'll go over the front end later, but it also has a RESTful API that you can use to integrate with your application. And one of the things we're working on is to have an actual grid bootable OS. So you plug the BeagleBone, Raspberry Pi, whatever PC you have, and it boots off the grid. That's kind of, the direction I'm trying to go. And our goal is to separate these concerns. So everybody has a concern, and I've talked to some people about their projects. They're concerned where they're going to store their data. They're concerned that, what they're obligated to give you. So we assume that any storage provider we use, like say we use Dropbox or anybody, we should assume that we're to get nothing from them, except for, here's a place to put your files. Good luck. So I guess I could go into it a little bit more. if I purchase, stores, let's say I buy Amazon S3, and I'm, in the cloud, and I'm have my files out there, and I'm having everybody work, everybody's happy, and I'm, and say they decide to bring their own bodyguard, which their firewall basically. I want to build a system in which I can still use that. So I want to still be able to use Amazon, and I want to still be able to use Dropbox and any type of Google Drive or whatever, but I want to be my own bodyguard. I want to be able to put my files out there, and I want to secure them how I think they should be done. I don't want them to tell me, oh, we're going to cover your files in candy and Christmas and everything be fine, because it's usually not the case. So I want to be in control of that of my data. And so this is what this file system is going to do. So we take all of this stuff that you see on the screen, and we do a simple collection, and we have clients. So this is the most basic overview of the grid. We have a collection of clients, and we have a bunch of storage servers. It doesn't matter what it is. It can be Google. It can be your own personal, drive. You may have a bunch of old drives you hook together, whatever. You can set this up in a ton of different ways. The beauty of it. You can even set up friend nets. So everybody that's your friend, provides storage for you. And this is kind of the idea that I had for the Hive, is that, we go to all these conferences. These things can be like door prizes. You give them out, you plug them in. Everybody's now setting up an internal grid in a huge conference. It would be kind of neat. You could play, capture the hash or whatever. You could do all kinds of things with it because the file structure is really unique. And everything that this thing does is dependent on one thing. Without this one particular thing, it's completely useless. And you're going to say, oh, well, it's a point of failure. Well, it's not necessarily true, because once you're introduced, you're introduced. It's like meeting somebody. You meet somebody, you're going to remember them. It's called the introducer, but it's a special service that helps nodes connect each other. All nodes connect to the introducer, both clients and storage servers. So without this, nobody knows where anybody is or where they come from. Now, what this also does is allows you to set up a unique principle, so you can actually go in there and set rules. You can say, okay, Alice, you're going to use this tub of storage. You're going to use this, and you're only going to have access to this stuff. These storage servers are offline. They'll never see that kind of stuff. That's all done behind the scenes. And the cool thing is, it's like, oh, well, now I'm liable, right? Because my introducer's out there, and it's on my network, and if somebody's doing something they shouldn't be, it's my fault. Well, that's not necessarily true either, because the only person that knows whose data is whose is the person that uploaded it, because it's encrypted upload. And I'll show that in just a couple of slides. But the client can be configured in numerous ways. Plain client doesn't offer up storage, so you'll never see it. So it's completely anonymous. So you have a client, which is the front end of Tahoe running on your computer, your whatever, hooking to your grid or whatever you're hooking it to with your application, with your API calls or whatever. You're going out to your storage. Your storage, it has file chunks that are sent to there by the client, and it uses an eraser coding. I'll get into that here in a minute. So we encoded upload. We use eraser encoding. Eraser, however you say it. But you have a ton of different shares. We take your file and we split it up. Let's say you had a 10-node Hive. And your Hive may have a ratio of 3 to 10. So what that means is you only need 3 of those servers to construct a valid file. So let's say 3/4 of your Hive gets compromised, or flooded, catches on fire, or whatever. It doesn't matter. You only need 3 of them. You only need 3 of these shares to put it all back together again. And basically, what erasure encoding does is commonly known as forward error correction. It splits the ciphertext into pieces. In such a way that you only need a subset of those pieces to recover the original. The Reed-Solomon algorithm is what this is using. It's an implementation, and it's fast, and it's really simple. So what we'll do is we'll send this encrypted file to different servers, and thus it'll tolerate failures of a configurable subset of them. So based on how we set up our grid, we can tolerate one-to-one failure, which is silly, but you know, we can tolerate many-to-one failure. We can tolerate any type of failure that we want to set up. So we're less dependent upon the availability of the individual server. So we don't care if Dropbox goes down. We don't care if they get hacked and, you know, it's the biggest thing on Facebook or whatever. What we do care about is our data still there? And if it isn't, fine, but when it comes back, we can still use it. So let's say half of your grid goes offline, right? Half of your shares get corrupted. Big deal. You know, those 3 shares in the middle are bad. And that's fine. And I have a great example to show you exactly how this all works. So all of these other files come in. They only need 3. In this case, we have 4, and we can construct our data. And if you see the link at the bottom, that's the how all this works. It's using a cipher algorithm called ZFEC. And this all goes to the storage. So you'll look at this storage server and you'll be like, all I see is a bunch of files labeled A through Z. And inside those files, you'll have a random file, which is completely unreadable, and at the top it says immutable Tahoe equals, and then it'll have a big hash. Using code time is how it's decided upon which storage server to put these on. So it's completely random. But each one has a unique key that it can put a copy of each one on each storage node. So in order for that to happen, you got to have the key. And only you have the key. Nobody else has the key. I don't have the key. The provider doesn't have the key. Whoever is on your friend net doesn't have the key. Only you do. You lose that key, you're SOL. You know, it's very, very unique to you. So once you do that, this is how you will grab the data back from the storage. So your key will link up with the storage index. The index will be able to grab the files that you need from whatever shares it finds out there, and it will be able to construct your file back again. So kind of an implementation of this, like in a common storage today would be like Dropbox or something. You know, not a lot of people go out and buy the MyBooks or whatever anymore. But you put your files and you get your files. You have a storage key, and then you get your values back from it. So basically what we're going to end up doing is we're going to take the HIVE. We're going to take our projects, and we're going to take what we're working on, whether it be OWASP or whatever, and we're going to insert it as a gateway in between these storage nodes. So then we know that we're submitting random storage to Dropbox and these other, free storage areas. And this is just one part of what the HIVE is in a whole. So we're coupling a competent PC that your project is on. You can use it for, training. You can use it for, building your projects. You can use it for workshops, whatever you want to do. But all the while, you have the opportunity to use the grid, and developing right now, we have demos and things and kind of test grids that we're trying to break. But in the long run, we want to be able to have a public grid where people can connect to these and can connect and share data back and forth and give people read-only access to that. And there's file caps and write caps and all that kind of stuff. I'll show you in the demo. So what I'm going to do now is I'm going to show you kind of how this all came about and what the different things look like. But first I want to show you kind of how the encoding works. Hopefully you guys can still see my screen. All right, so let's just say we want to encrypt a line of text. We'll just put ball in here for an example, okay? And what's going to happen is as soon as you do this on your client, it's encrypted already. So you're not uploading anything over the wire. Now, I'm using, an SSL certificate on my web front end because it is public, but you'd be silly not to do that anyway. So you encrypt it. It gives you this URL. I don't know if you guys can see this URL. It's very, very small here, but this is kind of just a representation of what the URL will look like. And these are your two keys. You got a key here, and you got a key here. This is what's used to retrieve your information. And this ratio here at the end is a 3-10-3 ratio. So we got a hive of 10, nodes in it, storage nodes. We need at least 3 to recover our file. So that's how we're going to distribute it across the board. Now let's say you have a huge grid, 500 nodes. You may want to increase that or decrease it. Now the higher you get in amount of servers that you need, the longer it takes to get your information back. So you will be able to see that. Let's see. So now we store it. So once it's stored, this is your node. This is your 10 storage node. You can see the V6, 4M. You see these weird little encrypted shares. They're to represent hashes. So let's say we want to recover our text. We recover it, and it's gonna recover using 1, 2, and 3 of the nodes. Now if we corrupt these, let's say they got corrupt somehow. Somebody came in here and hacked our storage. Let's corrupt a whole bunch. The grid is automatically going to recognize that those shares are no longer valid anymore. So now it's going to use 1, 4, and 7. So you can keep doing this. You can corrupting and putting back or whatever. And let's say you got a file and you corrupted your nodes. It has the capability to repair itself, and it will repair itself over time. So it'll crawl every 12 hours or whatever, and that's a setting you can set up to. So you crawl your grid with your introducer every day or so, and it will rebuild your structure. And it does that based on the user's input. So if it knows it has a bunch of unhealthy stuff in it, then when the user grabs their file or goes to the interface, it's going to have a little, information window that says this file is unhealthy, and I'm working on kind of making a better front end for that. So I'll show you what the grid looks like right now. So this is the front end. This is what it looks like. You got your introducer, URL or GUI or whatever you want to call it, and this is a unique. Basically, it's nothing more than a node, but it's acting as the introducer. This is going to tell us what all the storage servers are, where they're located, and their unique file, their node IDs. The helper is something that is very important when you're using a low speed system like a Raspberry Pi, for instance. When you upload a large file, it's very memory intensive. And for, price sakes, those things don't have that much memory. So it's a lot easier to use a helper node, which you can assign each one of these a helper. So if you have friends that are storage nodes, then they can be helpers. And when they get files uploaded to them, it will offload some of the work, kind of like a load balancer, to these other nodes so that they can disseminate that stuff across the board. And the storage servers, something that shows, the total disk space for this node. Now, we might have tons of terabytes everywhere, but unless we reserve that space or we give that space to people to use, nobody can use it. Us as clients, we decide what's going to happen. But this specific grid, for testing purposes, is public, and expiration is enabled, which means that the leases have an expiration time on them. So if nothing ever happens to a lease, say like you get a file and then you lose the key, so now you're going to start filling up your storage space with random stuff that you lost, and it's in the grid somewhere. Yeah, you can go in there and you can wipe all the shares out, and then whatever you want to do. But every 31 days or so, it will remove immutable and mutable files, which means it will take those shares and it will delete them. They're gone. Bye-bye. and it will crawl and it will look for the next times that these files were executed. So if it crawls, then it's going to renew your lease automatically. Now this is all extra credit type stuff. You don't have to have leases and stuff on your files. You can just have it store forever, but you'll fill up your grid pretty quickly. If you have a lot of people using it, people are just uploading random all the time. So with that said, buckets. Buckets are the storage. Tubs, buckets, whatever you want to call them. So this says there's 49 buckets. And sorry about that, ringing my doorbell. But anyways, what will happen is each storage node can be assigned different buckets. So you can go in there and assign one storage node 10 different buckets, however you want to do it. And if things get disseminated to those buckets, they'll start to register within the grid itself automatically. So you don't have to worry about all the complexities. Once this is up, it seems complicated right now, and it's not real concrete. But once this thing is up and running, it's very fail-safe. Yes, every now and then I'll get an error because I'll upload something and I'll have HIVE unplugged for whatever reason I was working on it. But it's very stable once it's up and running. So just as an example, I'll show what the directory structures look like and what files look at. So this is kind of what a directory would look like. You can make these directories in any form you want. You can even set up SFTP files that will automatically upload to the grid, so you can have your project files upload automatically every time they're put in there. And every time it crawls, which it does 2 crawls, it does at least expiration crawl, and it does just a regular system-wide function crawl. And when it does that initial crawl, it'll check those files and it'll upload whatever's in there. So you can set it to run every minute if you want. And kind of some kind of cool things I wanted to show off is, you can set up a secure wiki on here. So you can either set it as readable or non-readable, and it's using the Tahoe Labs secure file structure. So you can see up there that crazy URL. That is what it's using to generate this page. And if you want to, you can also do a read-only one. So there's 2 different types of files. There's read-only and readable. And so you got the readable or the read-only version here that will allow you just to view the latest version of the wiki. When you upload something, let's just do this real quick. Let's pick a file. Let's do this. And we're going to upload this JSON file, and there's immutable, there's SDMF, and MDMF. And the SDMF will allow you to actually change the file. So using the same crawl process, you change the file, it knows what you've done because it separates those files into containers. But for this instance, we'll just do an immutable file. And it'll upload to the grid. Right now, the grid that we're working with is a grid of 8 beagle bones. And they are the sole storage for this. And there's a small Atom blade server that I'm using for the introducer just because it was convenient at the time. But here we can check the immutable file structure. So we got our file recap and our verify cap. This is the file, this verifier that it uses to actually go out to the grid, and it's going to grab your information for you. So it's going to use this when you go get your file back. The API uses this similar type of fashion. If you look up here at the URL, you have obviously the base URL, and then you have the URI, and then This is kind of dumb. This is actually a colon, but this is how it's kind of separated up. So you know that that's going to check, which is going to verify, and then it's going to have this, which is the first part of the hash that's going to go out and initiate the connection to the index, storage index. And then the rest of this is going to go through and look for your file using that immutable erasure encoded share, and it's going to grab all your stuff and recompile all that stuff to your actual file. And then, so if you have a broke file, which I do on here, I have a bunch of broke ones. Let's say that let's see if that's good. All right, so we want to verify every bit. This is expensive, so if you have a huge file and you want to verify that this file is good, it's really important to you, you run this. This is a great benchmarking tool. It's kind of how I benchmarked how the Hive runs. When we're transmitting a bunch of files, I'll use this every bit verify. And what will happen is it'll go out to the grid, and it will verify every single thing that's on every single node to see if it has a share out there that it can put back together to get you a readable file from this. So you got share counts. You need 3 out of 10. We have 6. We need 10. So in order, because of this, it's not healthy. And there's no wrong shares in there. So if there's a share that's corrupted, it'll come up here and it'll say that share is wrong. And all this stuff is, you know, statistics type of junk. You can have an actual node be nothing more than a statistics node, and all it does is stuff like this. You know, so you don't have to worry about, you know, people bogging down your node or your grid getting bogged down. You can actually have a standalone node that does nothing but statistics, and actually you can have another node on top of that one that just generates hashes and keys. So anyways, what we'll do is, okay, so we know that this is now this is not a healthy share. So you can go in here and you can repair it. You can repair it. So what it'll do, it'll go out there, it'll grab the file that it knows because it's able to do it. If you can't get enough shares to, you know, reconstruct your information, you can't repair it, obviously. So what it's going to do, it's going to redistribute that lease back out to the grid. And you'll see this happen. So now it's healthy, the repair was successful, and now it's checking. It'll run a check real quick, and now we know that we have a share on every single node here. And that's the share IDs. So with that being said, that's basically kind of a high-level explanation of how this whole thing will work. The idea behind all this is to provide something useful to the OWASP community. Basically, anybody that's working with this, you can use this technology to do a ton of different type of. Oh, I have a question. Yeah, you can use this to do different kinds of shares. You can have each chapter could have their own grid if they wanted to. So you can set up a public grid. Let's say OWASP decides, oh, hey, I want to set up a public grid for OWASP. Then you can have that introducer act as in a public grid for everything, and people just connect to it and use it. And the share buckets can either come from your chapter, your area, your own private stash, whatever you wanted to do. So the possibilities are basically endless. And that was kind of the idea behind this, was to have something at OWASP to be able to secure data and overall be able to provide something that's shareable and tangible to the community. The whole aspect of this is very, very cumbersome. Like when I first started this, things failed. Things didn't work right. loading it on a Raspberry Pi. Everybody's like, oh, we just go out and buy a computer. Like everybody's got $900 to spend on a server or whatever. So the next best thing is to find something very cheap, very simple, and this could even be something that you could stick onto a badge. You can. My next project is to get this thing to run like as a root boot, so you can boot this thing up, and things will happen. Whatever's anybody's mind to do. And this project's open for people to come in and help and play with a Hive. I would like to build another Hive. I am using the Get Stuff Done project funds to build this one that you're looking at right now. But it would be ideal to have a few more Hives and be able to connect them together and interface with them, and possibly explore some other avenues of approaches to have multiple introducers and be able to restrict introducers to certain people. I mean, there's just all kinds of stuff that can be done here. And one of the really cool things about this is, it's just, say you're in a classroom environment. Everybody has a computer of sorts and whatever their deal is. And let's say you have a Hive there. Well, everybody can now experiment with the Hive, and you can store your information within the grid, whether that be log files, whether it be whatever the case is, but you can collaborate on a whole different level. So you're able to use cheap PCs, which you can hack them, break them, do whatever you want with them. You don't have to worry about jacking up your own PC or whatever. Then you can actually incorporate this into a learning environment, which is what this is all about. It's to learn things, and this technology is always being developed on. Least Authority developed this technology. I'm just kind of taking it to a whole different realm, and trying to get it out there so it's like, hey, look what this can do. And the cool thing about it is I already have, and I think there's one on here. I may have taken it down, but I used Dropbox as a storage node. Let's see if it's on here. No, I took it off. But I used Dropbox as a storage node just for proof of concept. So I used their free public storage as my own storage, and I don't really care if anybody gets the files, because there's not much they can do with them. They need 3 more servers to get, or whatever my ratio is, to get my data, and that is pretty cool to me. I mean, that gives you a peace of mind. That also gives you kind of a sense of ownership. I mean, yeah, you can take my data, or it relieves you of any type of liability. Like me, I host websites and things, but if I'm going to give somebody files and I'm going to store them and I can see them, I'm part liable because I know what's in there. But if I have this storage node and I'm going to show you exactly what it looks like, if I see, like, we have 5 minutes left, so hopefully I can get this done. If I can see what their files are, I'm liable. But if I don't know what they're doing, big deal. They can do it all day long. Oops. Let's see here. All right. Here we go. And one other thing that I'll go over too is, I wanted the ability to put this online, and I wanted the ability to secure it, because I thought, well, I don't want just random people uploading to my grid. I know it's public and everything else, and the one that's out there is right now. But if I was to do this for real and have, something public that I only wanted so many people to have access to, I wanted the ability to lock it down. So I used Authy, like a one-time token approach. So you have to have a one-time token, and it has to be set up on an account, which I was using WordPress to do that. So you get your token, put that in there, and then you get access to the grid. So you can kind of control who's getting into your grid at a higher type enterprise level versus, hey, everybody just start uploading, because, as people exploit that and all kinds of bad stuff will happen. So this is what the files would look like. Storage shares. So this is what the shares would look like. So on Dropbox and stuff, it will copy these folders out to their area, and this is all that's there. This incoming folder will actually have the incoming hash, and then what will happen is your client will actually destroy that file into these different shares. So here's one. We'll view this, and what happens is once your file in here, it's eraser encoded. So I mean, it's very, as you can see, I mean, it's not tangible. I'm sure, like, if you're the NSA and you have tons of time on your hands and $18,000 billion of taxpayers' money to throw at this, I would really be surprised if they could actually get a file to even show remotely what you're looking for, especially if you had a ratio of like 5 to 30 or something. 30 shares, you need at least 5, and say they had 2 in it. You know, they might get something. I don't know. It'd be interesting to have somebody actually have the skill to be able to decrypt something like this to see if it can even be broke. But at any rate, at the very bottom of this file, without a null mess in here, you can see the segments, the segment sizes, the share root hashes, and stuff like that, and what it needs to decode this. But without the actual key, it's useless. So that I was going to go over the sandbox, but I'm kind of running out of time, and I'm still kind of working on it. If you're really concerned about, seeing what's going on with the Hive, netgreen.us is the touch bounds for this. Anybody's more than welcome to go out there, take a look. It has the quick start guide for the BeagleBone Black. It has the downloaded OS that I'm using. It's nothing but a stripped down copy of DB and Wheezy. It goes in how to install Python, how to install all the dependencies, and how to build this thing. You can even fork my GitHub if you want. And you can also fork Tahoe Labs, and you can start experimenting on your own, building your own Tahoe Labs storage solution. And I mean, it's as simple as this command right here that says create node / welcome to the grid. You're creating a node, and that's what your node name is. And this is what this whole presentation is welcoming you to the grid, because I'm hoping that when I start this, that you guys' eyes and stuff like, wow, we could really do something cool with this. So I'm hoping that you feel motivated and you want to do more with this, because it's going to be kind of a game changer, kind of a project changer for OWASP, I think. And go forth and conquer. That is all I have. And I thank you for the people that are on. I'm not even sure if anybody is on, but I did have some questions. So there's at least one person listening.
Yep. Thanks, Jason. That's interesting. I see that there's a lot of potential practical applications for this, so that's great. And how do people get in touch with you?
I'm on. Let's see outside. I'm on Twitter as I am Jason Johnson, and also you can get a hold of me at jason.johnson@owasp.org. And if anybody wants to write that down, there's also the Tahoe Dev IRC channels. I don't know if anybody ever goes in those, but I'm in there 24 hours a day. So if you're in the Tahoe Dev channel, I'm usually in there trying to accomplish something, but that is my Twitter handle. There's also OWASP OKC on Twitter too. And if you go to netgreen.us, you just hit the contact page and hit me up, and I'll
Right.
try to answer everything I can.
Great. And if all else fails, you are the Oklahoma City chapter leader, so you can
Yep.
always connect to you through the Oklahoma City chapter. So that's awesome, Jason. If there are no more questions, then I think that's our presentation for the day. And I hope you have found this as interesting as I have. And we'll certainly be reaching out to Jason for some more information on this project. So thank you all
I'll
for
do it.
joining, and thanks, Jason.
You're welcome.
Bye.